Friends, now today we will discuss about basic characters of amine. In other words, basicity of amine. Basic character of amines, or in other words, basicity of amines. First we will take amines reacts with acid. Now any amine like RNH2 reacts with HX. In other words, HX is acid. Now amine reacts with acid and forms salt. So we can say that amine is basic in nature, because whenever salt is produced, one component it should be acid and one component should be base. So here HX is acid, so remaining part of RNH2 will be base. So we can say that when amine reacts with acid and forms salt, then we can say that amine should be basic in nature. Here aniline is given. Aniline reacts with HX and forms salt, so aniline is basic in nature. Here how the reaction is taking place, we will discuss. RNH2 reacts with HX, then H plus proton. Then H plus proton is attracted toward the non-bonding pair of nitrogen. That is why RNH3 is formed. Now remaining part X is as it is. So RNH3 plus dot X minus, which is salt. So we can say that salt is formed. And salt is formed, so we can say that amine should be basic. Now aniline reacts with HX, then H plus proton is attracted toward the lone pair electron of the nitrogen. That is why they form anilinium salt. This is ammonium salt and this is anilinium salt. Anilinium. I will write so amine reacts with acid and forms ammonium salt. Thereafter aniline reacts with HX and form anilinium salt. By both these reactions we can say that amines are basic in nature. Now this salt RNH3 plus X minus reacts with OH minus, that means reacts with base. This salt, it should be ammonium salt or it should be anilinium salt. This salt reacts with base, that means OH minus, and regenerate amine. So we can say that amine salt reacts with base and amine is regenerated. In this reaction, X will be removed. Here OH will remove with H, so OH and H will make water, and thereafter remaining part RNH2 is over here. So this is RNH2 and which will regenerate. So we can say that amine salt reacts with base and regenerate amine. But amine salts are soluble in water. Amine salts are soluble in water but insoluble in organic solvent. These amine salts are soluble in water and insoluble in organic compounds. Okay, now here amine reacts with water, in other words mineral acid. So amine reacts with mineral acid, that means water, and here H plus proton is attracted toward the non-bonding pair of nitrogen. That is why RNH3 plus is formed, which is ammonium salt, and remaining part OH will be as it is. So we can say that RNH2 amine reacts with mineral acid and forms ammonium salt. In this reaction, non-bonding electron pair which is attracted H plus proton, that means amine are Lewis base. Lewis base. By this reaction we can say that our amines are Lewis basic character. Repeatedly, amines reacts with water molecule. That means we can say that the lone pair electron of the nitrogen attracted the H plus proton. So protonation is formed. That is why ammonium salts are obtained and OH will be as it is. So by this reaction we can say that any component which are having lone pair electron and accept the H plus proton will react like Lewis base. So our amine is Lewis base. By this reaction we can say. Here the reaction is like this, and the equilibrium constant of this reaction will like this. Equilibrium constant KQ is equal to RNH3 plus and OH minus will be on upper part, and RNH2 and H2 will be on lower part. That is why the four terms will be like this: RNH3 plus OH minus upon RNH2 into water. But you know very well that in 11th standard we studied about the concentration of water. We studied about the concentration of water is 55.55 molar. So the concentration is constant. Here the concentration of water is 55.55. This is constant, and constant brings K equivalent. This is also constant. Now constant joins with constant and forms new equilibrium. Q EQ into water. That is why we can say that Kb is formed. So Kb is ionization constant of base. Kb is nothing but ionization constant of base. Here repeatedly we are going, the concentration of water is 55.55 molar. So this becomes constant. Now constant goes with K equivalent. So this constant goes with K EQ. So they forms new constant which is known as Kb, and this Kb is nothing but ionization constant of base. This Kb value is ionization constant of base. So this is 3 term, upper side 2, lower side 1, upper side 2, lower side 1, and the Kb value will be RNH3 plus into OH minus upon RNH2. Now this is ionization constant of base. If the Kb value will be higher, then they express more basicity. The substance which are having higher value of Kb, they express more basicity. And if the substance which are having lower value of Kb express that the substance are less basic. Repeatedly we are going further. Kb. If the Kb is higher value, Kb is having higher value and express more basic substance, and the Kb value will be lower. So it express that the base are less basic. Okay. So we are going further. pKb. Now as you know and studied in 11th science that pH is minus log of H plus. pOH is minus log of OH minus. Repeatedly like this. pKb. Similarly pKb is minus log Kb. So here the Kb is higher, then pKb will be lower because of minus sign. If Kb value is higher, then pKb value will be lower due to minus sign of this formula. And Kb will be lower, then pKb will be higher due to minus sign of this formula. So due to your inverse relation of Kb and pKb, inverse reaction of Kb and pKb. So if pKb is higher value pKb, if pKb is having higher value, then it will be less basic, and pKb will be having lower value, then the substance will be more basic in nature. Okay. Repeatedly, we are going further. pKb is nothing but the relation of pKb and Kb is like this. pKb is equal to minus log of Kb. If the Kb value is higher, then pKb will be lower, and Kb will be lower, then pKb value will be higher. Now, you know very well that if more value of Kb express more basicity and less value of Kb express less basicity, but here the inverse relation of Kb and pKb, due to inverse relation of Kb and pKb, then the pKb value is higher. If pKb value will be higher, then substance will be less basic, and pKb value will be lower, then substance are more basic. Okay. Okay. Now we are going toward aryl amine, alkyl amine, and ammonia. By the data forms of pKb, by the values of pKb, we can say that aryl amine are less basic. Alkane amine, this is alkyl, this is amine. Alkane amine are more basic, and between these alkane amine and aryl amine, ammonia is in between them. Here, why alkyl amine? Why alkyl amine or alkane amine is more basic, we will discuss. And why aryl amine are less basic, we will discuss. Here, alkyl amine. Now, what is the nature of alkyl? What is the nature of alkyl group? Alkyl group is having electron donating nature. So R is having electron donating nature, electron releasing nature. That is why the nitrogen, the electron density on nitrogen will be increased. Why? Because alkyl group, which is electron donor group, that is why it donates the electron toward the nitrogen. That is why the electron density on nitrogen will be increased. That is why we can say that alkane amine are more basic. This is more basic substance. But inverse reaction is there. In aryl amine, aryl group are having electron withdrawing nature. Aryl group are having electron withdrawing group, which are having electron withdrawing nature. That is why they accept the electron. They accept the electron from the nitrogen. So electron density on nitrogen will be decreases. So all the electrons of nitrogen will be going toward aryl group. So aryl will electron withdraws from the nitrogen. That is why electron density on nitrogen will be decreased. That is why we can say that aryl amine are less basic. Are less basic. There is no any electron withdrawing group or electron accepting group. That is why ammonia is in between them. So we can say that alkane amine are more basic, aryl amine are less basic. But the basicity of amine, there are so many factors which are affected on the basicity. There are so many factors which are affected on the basicity of amine, like plus I effect, inductive effect, second one solvation effect, and thereafter static hindrance. These three factors are affected on the basicity of a base. Okay, let me discuss further. Repeatedly we are going. Here amine reacts with HX. When amine reacts with HX like acid, then they form salt. Similarly, aniline reacts with HX, acid, then anilinium salt is obtained. So we can say that when amine or aniline reacts with acid and forms salt, that means we can say that our amines are basic in nature. Now amine salt reacts with base and regenerate amine. These amine salts are soluble in water and insoluble in organic compounds. Now amines reacts with mineral acid like water, then they form ammonium salt. In this reaction we can obtain equilibrium constant. Now equilibrium constant will be RNH3 and OH minus will be upper on side and RNH2 and water will be lower side. So this is the terms of K equivalent. But you know very well that the concentration of water will be 55.55. This is constant value. Now constant goes with the constant and make new constant like Kb. So Kb is nothing but ionization constant of base. Kb value will be ionization constant of base. So Kb is RNH3 plus into OH upon RNH2. If the constant like Kb, if this Kb value will be higher, the value of Kb will be higher, then will known as more basic substance, and the value of Kb will be lower, then the substance will be known as less basic substance. Okay, less basic. Kb value higher, then more basic. Kb will be lower, then less basic. But this is correlation. This is correlation between pKb and Kb. As you know that pH is nothing but minus log of H plus. That means H plus and pH which are having correlation. That is why here Kb and pKb also having correlation, like pKb is minus log of Kb. If the Kb will be lower, then pKb will be higher due to minus sign, and Kb will be higher, then pKb will be lower. So by these values, by this correlation, we can say that if pKb value will be higher, then less basicity, and pKb will be lower, then more basicity of the substance. Okay. Thereafter, relation of alkanamine, arylamine. Now, alkanamine, which involves R group, and arylamine, which indicates AR group. So, in alkanamine, there are alkyl group which donates the electron toward the nitrogen. In alkanamine, R group, which is alkyl group, which shows plus I effect. That is why we can say that they donate the electron toward the nitrogen. So the electron density on nitrogen will be increased. That is why RNH2 reacts like more basic substance. Repeatedly, we are going R having electron donating nature, electron releasing nature. That is why due to electron releasing nature, the density on nitrogen will be increased. That is why RNH2 become more basic. But here ARNH2 in arylamine, aryl group are electron withdrawing group. That is why electron withdrawing group, so they withdraws the electron from the nitrogen. That is why the electron density on nitrogen will be decreases. So arylamine are less basic. In between arylamine and alkanamine, ammonia will be present. The factors affected on basicity are three factors. Number one, plus I effect, inductive effect. Second one, solvation effect. And third one, steric hindrance. Okay. Students, now we will discuss about basic character of amines, basicity of amines. Here, first we will take alkanamine versus ammonia, and thereafter benzenamine versus ammonia. Here, alkanamine versus ammonia. In this topic, three affected like plus I effect, second one solvation effect, and third one steric effect, steric hindrance we will discuss. First one, I effect, plus I effect. Here ammonia is given. Now nitrogen, which are having lone pair electron, due to lone pair electron on nitrogen, H plus proton will be attracted. That means protonation will be occur. So ammonia will be basic in nature. This is basic substance. But when hydrogen is replaced by one alkyl group, that means one alkyl group is present over ammonia and forms primary amine, then this alkyl group, this methyl group, which is electron releasing group, that is why electron density on nitrogen will be increases, so protonation will be occur very fast, rapidly. That is why it becomes more basic. So primary amine will be more basic than ammonia. But in this case, 2 hydrogen will be replaced by 2 methyl. That means 2 degree amine will be occur. These 2 degree amine which are having 2 methyl group, these 2 methyl, these 2 alkyl group release the electron because they are having I nature plus I effect plus I nature. That is why they release electron. That is why the electron density on nitrogen will be increases. That is why protonation will be very fast. Protonation will be done very fast and rapidly. That is why 2 degree amine will be more basic than 1 degree amine. Right? Thereafter, 3 hydrogen will be replaced by 3 alkyl group. That means 3 methyl group. That is why they are having electron releasing nature. So they donate the electron to the nitrogen. So electron density on nitrogen will be increased because 3 alkyl group donates the electron. That is why they are having more electron density. That is why protonation will be very fast. Protonation occur will be very fast, rapidly. That is why 3 degree amine is more basic. So we can say that in this gaseous state, this ammonia, primary amine, secondary amine, tertiary amine, these 4 substances are in gaseous in nature, gaseous phase. In gaseous phase, 3 degree amine are more basic. 3 degree amine are more basic and 1 degree amine are less basic. But whenever we will discuss about aqueous phase, in aqueous phase, 3 degree amine are less basic and 1 degree amine are more basic. How it will be? We will see. Now here, this is primary amine, this is 2, that means secondary amine, and this is 3R, that means tertiary amine. Now, primary amine reacts with the H plus proton and forms ion of primary amine. This is ion of secondary amine. This is ion of tertiary amine. But in ion of primary amine, they are having 3 hydrogen. So water will reacts with the hydrogen and forms solvation. So in primary amine, there are solvation phenomena will be on 3 places. Here, here and here. So we can say that solvation is more in primary amine. But here, secondary amine, the secondary amine contains 1 and 1, 2 hydrogen. That is why solvation will be on 2 sides. There is 2 sides of solvation and here 1 side solvation. So as we know that this is the ion, size of ion is less. Here size of ion is more. Here size of ion will be greater. When greater the size of ion, solvation became less, and solvation became less. That is why they are less basic. So 3 degree amine will be less basic and primary amine will be more basic. As we know that primary amine contains 2 hydrogen, but 1 hydrogen is more because of nitrogen which are having lone pair electrons. So they accept 1 hydrogen. That means they are having 3 hydrogen. So primary amines make solvation on 3 sides. secondary amine makes solvation from two sides and tertiary amine makes solvation from one side. So we can say that as the greater size of ion, here size of ion will be less and size of ion will be more over here. So as the greater size of ion, the solvation becomes less, and solvation became less, that means basicity will be also decreases. So here 3 degree amine possess less basicity and 1 degree amine possess more basicity due to more solvation. So here greater size of ion, less solvation, and less solvation, that means less basic substance. Here solvation will be more, that means more basic, solvation is less, that means less basic. So in aqueous phase 1 degree amine is more basic and tertiary amine will be less basic. But in gaseous phase 3 degree amine is more basic and 1 degree amine will be less basic. Now here student, third phenomena, the factors affected on the basicity. First one, plus I effect. Second one, solvation effect. Now third one, steric hindrance. If the methyl, ethyl, propyl, more bulky group will be attached toward the nitrogen. Here methyl, ethyl will be attached toward the nitrogen. Then electron repulsion will be also there. That is why steric hindrance will be occur. So we can say that in aqueous phase, if methyl is given, then 2 degree amine is more basic and 3 degree amine is less basic. But when ethyl is given with the nitrogen, then 2 degree amine will be more basic and primary amine will be less basic. Here 2 degree amine more basic, 1 degree amine less basic, and 3 degree amine will be very less basic. But in ethyl amine, we can say that diethyl amine will be more basic than triethyl amine, and triethyl amine will be more basic than ethyl amine. So we can say that this is 2 degree amine, this is 1 degree amine, this is 3 degree amine. And here 2 degree amine, 3 degree amine, 1 degree amine. So steric hindrance is also affected on the basicity of your substance. Okay. Now students, we will discuss about ammonia versus aryl amine. Here, why aryl amine, which are having less basicity due to resonance? This is the answer. How it is possible? We will see. Here aniline is given. Now aniline contain nitrogen and nitrogen contain lone pair electron. These lone pair electron will be disappear in these three cases in resonating structure. So we can say that these lone pair electron which will be delocalized in benzene ring, that is why less available electron density on nitrogen will be found. Here electron is there, here not present, not present, not present, and here present. So we can say that the electron of nitrogen, the lone pair electron of nitrogen, which will going to the benzene ring, and due to going to this benzene ring, delocalization is there. Delocalized, due to being delocalized electron, due to being delocalized electron, the tendency of accepting H plus proton will be decreases. So these aniline will accept the H plus proton not very fast, not rapidly. That is why they becomes less basic. Here we will discuss about resonating structure. First one, this nitrogen is having lone pair electron, but at that time this electron is going toward this carbon and nitrogen. Between carbon and nitrogen, these two electrons going, that is why double bond is formed and nitrogen becomes positive. So at that time this electron is, the bond electron will be going toward this carbon, so it will make minus charge. Now this two bond is as it is, but in this reaction this electron will be going toward this carbon, so it will be minus, it will be minus, and it will be plus. So plus minus will be attracted and form bond. That is why this electron is going toward this carbon, that is why they makes negative charge. And here should be positive, negative will be attracted, that is why double bond is formed. And here the electron, this electron, bond electron will be going toward nitrogen and nitrogen becomes negative. So negative positive attract and makes neutral atom. So this becomes plus and minus will be attracted and forms bond. So these five resonating structure will express, these five resonating structure, they express that the electron density on nitrogen will be decreased. In 5 cases, only 2 are having electron pair on nitrogen. That is why they accept the H plus, not very rapidly, not very fast. That is why they became less basic. Less basic. So we can say that due to resonance, the electron pair on nitrogen which will be delocalized, that is why the electron density on nitrogen will be decreased, and due to decrease the electron density, it will become less basic. So aniline is less basic than ammonia. So aniline which is less basic than ammonia. Okay. Thereafter we will discuss about the protonation on aniline. What will form? By protonation on aniline, they accept the H plus, that is why it will make anilinium cation, and due to resonating structure they possess two type of anilinium cation structure. One is this and second one is this. So we can say that due to resonance in aniline, the electron density on nitrogen will be decreased due to going toward the benzene ring. That is why they possess less electron density. That is why they accept H plus proton not very rapidly, not very fast. That is why it becomes very less basic. So aniline is less basic than ammonia. Now, in this case, whenever aniline possess OCH3 group and CH3 group, these two groups are electron donating group. If we are joining this group, toward the aniline, if methoxy, methyl, this type of electron donating group is attached to the benzene ring, then what will happen? Then the basicity will be increased. Basicity increase. But in aniline, this is electron donating group. These groups are electron donating group. So these electron will go toward the nitrogen, and nitrogen is having more electron density. That is why they becomes more basic. But whenever nitro group is nitro COOH, this type of groups is attached toward the aniline, then Their group accept the electron from the nitrogen. That is why nitrogen becomes less electron density. That is why it becomes less basic. So we can say that when methoxy, methyl, this type of group is attached toward the aniline, aniline becomes more basic, and nitro COOH group is attached toward the aniline, then these groups are electron withdrawing groups. That is why it becomes, aniline becomes less basic. Okay.